Hello, good morning. I'm the second presentation entitled Thermal Effects of Trees and Green Roofs in Urban Areas in Cebu City. Trees reduce temperature by blocking sunlight, providing shade to shelter you and your home from the heat. Urban trees intercept the sun's radiation before it reaches the ground. Additional cooling occurs when water evaporates from the leaf surface, known as evapotranspiration. Evapotranspiration takes place when the sun's rays hit the tree's canopy, resulting in water evaporating from the leaves. This cools the trees down, much like sweating cools our skin, reducing the amount of energy left to warm the air. So a green roof or a living roof is a roof of a building that is partially or completely covered with vegetation and a growing medium planted over a waterproofing membrane. So here's an example of a green roof. Green roofs serve several purposes for a building, such as absorbing rainwater, providing insulation, creating a habitat for wildlife, and decreasing stress for people around the roof, uh, providing a more pleasing landscape, and helping to lower urban air temperatures and mitigate the heat island effect. So here are some examples of green roofs. Then for our study area, Cebu City is a highly urbanized city located in the middle of the eastern coast of the island province of Cebu in Central Visayas region. It has 80 barangays subdivided into two congressional districts. And then barangays closer to coast are generally smaller and more densely populated and primarily residential or industrial, while barangays towards the northwest, this one, are generally larger and less economically developed. A feature of Cebu City, which is common to many cities and municipalities in the province of Cebu, is that the administrative boundary encloses an area with a large variation in elevation. So from sea level here to elevations of up to 900 meters above sea level here in the uh, higher elevation in rural areas. Then for our simulation sites, we have two sites. First is Cebu IT Park, which is located at the prime area of the city. So Cebu IT Park is a 27-hectare global gateway of local and international IT, BPOs, and R&D companies with shopping centers and recreational facilities. And the sidewalks and center islands of Cebu IT Park are surrounded by Nara palm trees and also shrubs below the trees. Second area is Fuente Osmeña Rotonda, which is located in the heart of the city of Cebu. So Fuente Osmeña Rotonda is surrounded by commercial establishments from restaurants, fast food chains, hotels, casino, and malls to financial and health centers and clinics. And at the middle of the Fuente Osmeña Rotonda is a plaza or a park that has benches and a lot of acacia, mahogany, and other trees. So for our simulation, we have to get our data. So this one, the digital surface model from LiDAR derived data, and also the digital terrain model. And from these models, we can obtain the normalized digital surface model where we can extract the elevation or the height of, let's say, some features like buildings and trees. Then from these layers, we can extract the height of buildings, height of trees, and also the length of the roads. So for the materials used for the building and also the presence of the trees, we have to validate and annotate in the field. So thanks to the Cebu City LGU for the help in annotating and validating the materials of the buildings and trees. And after that, after gathering the data, we can have the NVMet model. So for Cebu IT Park, we'll have this model for microclimate. So the uh, gray rectangles are the buildings, the green are the trees and shrubs, the yellow are the soil, and this one for Puente Osmeña Rotonda. Then for the initial condition, the temperature, humidity, wind speed, and direction are from darksky.net. And we also validated these values using temperature sensors. Then the simulation date is 21st of April in 2019. We chose this date because it is a clear day, no clouds, and also we have a satellite pass on this day. Then simulation time is from 6 a.m. to 6 p.m. And then for this NVMet model, these two would be our scenario one or the actual scenario. And we will also have two different scenarios, two more scenarios, which is the no tree scenarios, where the trees on the model, we remove all the trees in the model. So there are no more trees here in Cebu IT Park, and also no more trees here in Fuente Osmeña Rotonda. Then the next scenario is the green roofing scenario, where from the actual scenario, we replace the roof with green roofing. So the green roofing is regardless of the type of roof present in the area. And then for the results, so this one is for Cebu IT Park. So this is the temperature difference from the actual scenario and the no tree scenario in Cebu IT Park. As you can see here, there's a red zone in 1 p.m. So remember, this indicates that there is an increase in temperature when the absence of trees, which is around zero point 0.2 increase, zero point 0.2 degrees Celsius in increase on air temperature at 2 meters above the ground. So we are measuring the temperature at 2 meters above the ground. For the green roof, as you can see here, only in this part has an effect for uh, decreasing the temperature for around zero point 0.1 degrees Celsius. And then this building here has a height of around 8 meters. Unlike the other buildings here, which is around 50 to 60 meters. So we can say that at 2 meters above the ground, only low-rise structures have effect on the green roofing. I mean, on the temperature for green roofings. So let's visualize the warming up of Cebu IT Park on the left side here. And on the right side is the shadow of the buildings in Cebu IT Park. So as you can see here, from 6 a.m. to 9 a.m., the shadows of the buildings cover a large portion of Cebu IT Park, which means that it also helps in cooling the area. And also for 3 p.m. onwards. That's for Cebu IT Park. Now let's go to Puente Osmeña Rotonda. So let's focus here at 1 p.m. for the temperature difference of the actual scenario and the no tree scenario. So as you can see here, there is a red spot here and also this one. So these red spots are where the trees were supposed to be. So at 1 p.m., which is the hottest time of the day, the absence of trees makes the air temperature at 2 meters above the ground relatively higher by 1 degrees Celsius. So from the actual scenario. So removing of trees will increase the temperature of the air temperature at 2 meters above the ground by 1 degrees Celsius. And for the actual and the green roof temperature difference, as you can see here, so there are a lot of blue zones, which means that uh, the air temperature at 2 meters above the ground is cooler for the green roof compared to the actual uh, scenario. So it's much cooler by zero point 0.3 degrees Celsius. So, and the buildings here in Puente Osmeña Rotonda have a low-rise buildings. So from 20 to 30 meters in height. So let's see the uh, warming up of Fuente Osmeña Rotonda on the left side. Then on the right side is the shadows of the building in Fuente Osmeña Rotonda. As you can see, the shadows of the buildings in Fuente Osmeña Rotonda is not that long compared to the Cebu IT Park buildings, which has a much longer shadow because of their structure, which is high rise. So observations and mitigation recommendations. So absence of trees may result to an increase in air temperature by at least 1 degree Celsius. So we recommend to plant more trees along the sidewalks, center islands, and in parks to have more shade and cooling. And then another observation, green roofs has much cooling effect in reducing the air temperature. It was also observed that green roofing for low-rise buildings has greater impact on the air temperature at 2 meters above the ground than high-rise buildings. And furthermore, based on a study conducted by Batista and colleague in 2016, adoption of the green roofs in Rome showed a lowering of the vertical air temperature profile in morning and at night. So we recommend that we have to have green roofing to mitigate and lower the air temperature in the city. So that's it. Thank you for listening.